In the world of AI, there's this mantra we hear over and over. More data is better. But what if that's not just wrong? What if it's a complete lie? What if the very thing you think is making your model smarter is actually making it dumber? This is one of the most dangerous traps in all of data science, and today we're going to learn exactly how to spot it and how to avoid it.
I mean, it's a scenario that stumps even seasoned pros. You spend all this time meticulously gathering more features, more context, you feed your model this absolute feast of information, and its performance just nosedives. So what's going on here? How is that even possible?
Yeah, this quote it nails it. And listen, this isn't some small niche technicality. This is a fundamental barrier in AI. It's called the Curse of Dimensionality, and getting your head around this is what really separates the pros from the amateurs.
Okay, so to really get this, let's just forget about all the complex math for a second. We need to actually visualize what these dimensions are doing to our data. Let's think about it in terms of simple, everyday space.
So picture this. You've got 10 data points just sitting on a simple line, one dimension, right? They're all packed in there, pretty close to each other. It's easy to spot patterns, easy to see which points are neighbors. The line is pretty well covered. Everything's nice and dense. All right, now let's add just one more dimension. We'll turn that line into a square. And all of a sudden, those same 10 points are scattered. They're way more spread out. You can see the empty space just exploding between them. The density is dropping fast. And this is where it gets crazy. By the time we go to 3 dimensions, a cube, our 10 little points they're like tiny specks of dust floating in this huge empty void. The volume of that space has absolutely exploded, and our data has become incredibly sparse. And get this, to keep that same density we had on the line with just 10 points, you would now need 100 points to fill out the square and 1,000 points to cover that 3D cube. 1,000. The amount of data you need just grows exponentially. And that, my friends, is the curse of dimensionality. It's this phenomenon where as you add more features, more dimensions, the space your data lives in just expands at this mind-blowing rate. So fast that your data points become super sparse, totally isolated. Basically, they get lost. And, this isn't some brand new concept. The term actually goes all the way back to the 50s. A mathematician named Richard Bellman coined it when he realized that problems got exponentially harder to solve with every new variable. Today, it's a fundamental warning in AI, and it really, really hits hard when your number of features completely dwarfs the number of actual data samples you have. Okay, I absolutely love this analogy. Think about it like this. Finding a pattern in your data is like looking for a needle in a haystack. In one dimension, that haystack is just a single line of hay. Easy, right? But with every new dimension you add, the haystack doesn't just get bigger, it grows exponentially. You're searching for a needle in a haystack that's basically ballooning into the size of a universe. You could also think of it this way. It's all about loneliness. In low dimensions, every data point has friends, right? It has nearby neighbors that give it context. But as you keep adding dimensions, each point just gets flung out into its own lonely corner of this vast space. It becomes totally isolated, and that's where the trouble starts. Okay, so what? Our data points get lonely? Big deal, right? Well, it is a huge deal. Because when data points don't have any neighbors, all the algorithms we rely on, they just break. They get completely lost. Let's look at exactly how this happens. This chart right here shows the whole paradox in action. You see, as we add a few features, performance gets better. Great. But then it hits this peak, this sweet spot. And after that, every new feature you add actually makes performance worse. It just nosedives. The model is literally choking on all that extra noise. And this is just catastrophic for so many machine learning models. Take something like k-nearest neighbors. It's built entirely on the idea of finding close data points. Well, that becomes totally useless. Clustering can't find meaningful groups. And here's the worst part. Your models start to overfit. They stop learning the actual real patterns, the signal, and they just start memorizing the random noise from those isolated training points. So here's the really weird, counterintuitive geometric fact. In a really high-dimensional space, the distance to your nearest neighbor and the distance to your farthest neighbor become almost identical. And if every point is far away, then the whole idea of distance, which is the bedrock of so many algorithms, it loses all its meaning.
Okay, I know that sounds pretty bleak, right? But this is not an unsolvable problem. Not at all. The smartest minds in this field have figured out some incredibly clever ways to beat the curse. And the secret isn't always more data. It's about finding the hidden, simpler structure that's already there. And this brings us to our secret weapon, the concept of a manifold. So here's the idea. Even if your data has, say, 1,000 features, the really important information, the real pattern, often lies on a much simpler shape that's kind of embedded inside that massive space. Think of a single elegant thread woven through a giant messy tapestry. Our job? It's to find that thread. So the escape plan is actually pretty elegant. Step 1, you find that hidden structure, that manifold. Step 2, you project your data down onto it. You're basically squashing it, throwing away all that useless, empty, noisy space. And just like that, your data becomes dense again. Neighbors are close to each other. Distances mean something again. You've cured the curse. So in practice, how do we do this? Well, there are two main strategies. First up is feature selection. This is where we act like detectives, right? We're sifting through everything to find and keep only the most important, most informative features. And then there's dimensionality reduction. Here, we're more like artists. We're taking lots of features and creatively combining them into fewer, brand new, super powerful summary dimensions. So, after all that, what's the big lesson here? It's a really powerful idea that honestly goes way beyond just data science. In a world that is obsessed with more, the curse of dimensionality is this perfect reminder that sometimes less is actually profoundly more powerful. I think this quote just wraps it all up perfectly. When we just carelessly add more dimensions, we think we're adding richness, but we're not. We're just diluting our data into this vast emptiness where every single point is an island and finding a real pattern becomes impossible. And look, this really drives the point home. Real clarity, real understanding, it doesn't come from just piling on more and more detail. It comes from being smart, from simplifying. It's about having the discipline to find those few things that really matter and focusing on them like a laser. And that's the idea I want to leave you with. In this age of so-called big data, maybe the real challenge isn't about collecting more of it. Maybe the real genius lies in having the wisdom to simplify, because sometimes the most powerful story is also the simplest one.